Hi, we're still in Unit 6, and this is Video 6, and we're going to practice naming ionic and molecular compounds. We are not going to learn anything new, we're just going to try to tie everything together and practice. All right, the very first step in naming these compounds is to determine if it's an ionic or a molecular compound. But how are you going to tell? Well, the first thing you have to do is you have to look at the beginning of your compound. Is there a metal present? Or is there the polyatomic ion ammonium present? So just in case you've forgotten, the polyatomic ion ammonium is NH4 with a +1 charge. Now, ionic compounds are composed of cations and anions, and the metals form the cations, and this is the only polyatomic ion that we've learned that is a cation. So we're looking for a metal or the ammonium ion. And in case we've forgotten, I put in a periodic table here, and notice that all the ones in red, those are the metals. All right, so just remember the metals are on the left side of the periodic table and take up about 75% of it. Then we have the nonmetals here in blue, things like nitrogen, oxygen, chlorine, fluorine, bromine, carbon. Also remember hydrogen is a nonmetal. And then all these ones that are borderline in between the metal and the nonmetals, they can be called semi-metals. They're called metalloids. All right, so let's look at these following compounds and identify them as molecular ionic. If they're molecular, we'll write an M. If they're ionic, we will write an I. So we are looking for metals. So I'm scanning through here and I see iron is a metal. That means that this is ionic. Oh, aluminum's a metal, so this one is ionic as well. And again, here we find zinc, and that is ionic. You'll always have a periodic table in front of you, but it won't be color-coded with the metals and the nonmetals. So it's always good to know where to draw the staircase and to realize that to the left of that staircase is where you will find the metals. All right, we also, to identify something as ionic, we need to be on the lookout for that polyatomic ion ammonium. And I see it here. So notice there is no metal. Nitrogen and hydrogen are nonmetals, but this is a polyatomic ion that has a positive charge, which makes it a cation, which will be in our ionic compound. Okay, so we've identified our ionic compounds, so this must make this one, see that beginning element there, that's a nonmetal, so yes, that's molecular, and sulfur, yes, that's a nonmetal, so that would make it molecular. Okay, that's a really important first step when you're naming these compounds. Be on the lookout for the metals. Know if you're naming an ionic compound or a molecular compound, because the rules are different. All right, let's start with the molecular. Okay, so we identified this one as molecular, and we identified this one as molecular. Okay, when you have a molecular compound, that's when you use the prefixes. You never start with the word mono, and you always have the ending "ide." So let's name our two molecular compounds that was in this list. Two nitrogens. We have two nitrogens. The prefix for two is di, so it is dinitrogen. Two nitrogens, and we have 5 oxygens, and the prefix for 5 is penta, and we're going to end in ide, dinitrogen pentaoxide. All right, let's go down here to our other molecular compound, and we've got 1 sulfur there, so that would be mono is the prefix for 1, but we don't ever want to start the name of a compound with mono. So we simply say sulfur. We have 2 oxygens, and the prefix for 2 is di. So that is sulfur dioxide. Okay, that's using prefixes for molecular compounds. The rules are fairly simple. You use prefixes, never start with mono, always end in ide. Alrighty, now, step 2. If it is ionic, we've got to check out the metal. That cation part at the beginning. Is it a metal that always has the same charge, like group 1A and 2A metals, they're always +1 and +2? Is it ammonium? Okay, if it is, we're ready to name it right now. All right. I also want you to remember that these will end in "ide" unless it's a polyatomic ion. If it's a polyatomic ion, you just name the polyatomic ion. A lot of times they end in "ate" or "ite," and there are a few that do end in "ide," but just never change the polyatomic ion's name. All right, well, we have already named this one and this one because they were molecular, so let's have a look here. Oh, that's ammonium. Okay, so we said let's just go ahead and name it. That would be ammonium. Never change a polyatomic ion's name. And the ending would be chloride, ammonium chloride. Iron. Oh, iron is one of those metals that changes charges. It's a transition metal, so we're not going to name this one yet. Aluminum. Aluminum is a metal that always has the same charge. Do you remember what it is? Aluminum is always +3. So we can just go ahead and name it. This is aluminum, and we have a polyatomic ion. This is one of the polyatomic ions that ends in "ide." OH- is simply hydroxide. All right, how about this one? Zinc is a transition metal. It is all the way at the end of the 3D block where all of the electrons are paired. It's diamagnetic. It always has a +2 charge, so we don't have to worry about figuring out its charge. We're just going to name it zinc, and the polyatomic ion is acetate, zinc acetate. Okay. Now, step 3, if it's ionic and we check out our metal, you know, that cation part at the beginning, if it's a transition metal or if it's a metal that's to the right of the transition metals that doesn't always have the same charge, we need to figure out its oxidation number, its oxidation state, or in other words, its charge. And then we're going to put that charge in parentheses after the name of the metal. Okay, here we go. All right, I just wanted to show you this periodic table again and point out aluminum is always +3, so we don't have to use Roman numerals with aluminum. Zinc is always 2+. We don't have to use the Roman numeral 2 with zinc. And silver is always +1. It makes this nice little staircase. See, 3, 2, 1, like going down the steps. 3, 2, 1. So don't use Roman numerals in parentheses with these metals, even though, yes, silver and zinc are transition metals and so forth, but you don't need the Roman numeral because they always have the same charge. Also, gallium is always +3. You don't need to say gallium 3, but mainly it's the aluminum, zinc, and silver I'm worried about. All right, so here we go. Let's go back again. I'm sorry. Look at the iron here. That is smack dab in the middle of our transition metals, and we didn't memorize like a charge for it. It's not the same charge all the time. This is a case where we do have to use a Roman numeral in parentheses following the word iron to indicate its charge. So here we go. We've already named this one. We've named this one, this one, this one, this one. Here we go. It's a transition metal that can have different charges. So how do we figure out the charge on the iron? Well, let's look at the negative portion of this, SO4. We have to know, if you're in honors chemistry, by memory. If you're in standard chemistry, you can look it up, that sulfate has a -2 charge. All right, sulfate is -2. The overall molecule doesn't have a charge at all. So the negatives and the positives have to be balanced out. If sulfate is -2, then the iron has to be, to make it have no overall charge, it has to be a +2. All right, remember we practiced quite a bit with oxidation numbers in class. So let's go ahead and name this. It is iron sulfate, and we have to put the charge in parentheses with Roman numerals. We figured out the charge on that iron is +2, so that is iron 2 sulfate. Well, I hope putting all this together has helped you see all the different steps you have to go through to get a correct name on a molecule or a compound. And so we're just going to practice, 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 and hopefully this will become like second nature before long. Have a good night.